Good afternoon. Today we'll move on to the second part of the stat analysis where we analyze a portal frame. So we'll move on to the analysis. So first take the software stat file, new, we'll name it as structure 2 and we'll save it in same file which I have saved earlier. So change the units to meter, kilonewton and take it as plane. Next add beam, finish. So first we'll add the nodes, it is the 0, then we'll add the 0, 4, the second node. So coming back, add the beams in between these nodes. Now in order to make this as a portal frame, select and move on to the geometry where we have an option called a translational repeat. So in this we can select the direction is along x direction and here the distance is 3 meter, number of steps in this the spacing is 3 meter, the default spacing is 3 meter, number of steps 1 and give the OK. So we get another which is moving along in the x direction. Now join these two nodes, then we'll have the select, call the 3, select all the 3 beams, use the option translational repeat. We'll move it along vertical direction, that is along y direction. Then the default spacing is given as 4 meter, a number of steps is 1 and give OK. So you get another beam, another frame. Now the next option, that is we have completed the geometry, then moving on to the general. First is the property, we have to define the property. So define a rectangular property, we'll have two different properties here. First the rectangular property in which depth is equal to 0.4 meter and width is equal to 0.3 meter. Add another beam with depth is equal to 0.6 meter and ZD width is equal to 0.3 meter. Add. Therefore we have two sections. First rectangle, that is the first section will give it to the columns, that is assign, use cursor to assigning assign for the columns, then select next one, will assign to the property, the beams we assign to the columns, use cursor to assign, we have assigned for the columns or for the beams. So the sections is over. Now this is specifications, there is no particular specification. Moving on to the support. We create two supports, that is create, first is a fixed support and the next is a hinged support, that is pinned. Add. So first is a fixed support, assign, use cursor to assign, that is a fixed support, and the next one use cursor to assign, that is a hinged support. Now after the support definition, moving on to the load and definition. So first load cases, add. So in this, let it be live load. So we'll have load case 1, that is mark it as live load, mark it as live. So add, close. So in the live load, add. So first is we'll have a nodal load, that is in here we'll have a horizontal loading at the nodes. So in this case horizontal is fx. So horizontal is fx here, fx positive direction, fx. We'll have a 20 kilonewton load, and we'll have another one along x direction, 10 kilonewton load. And so we'll assign this first. Fx is equal to 20 kilonewton at the top node, and Fx is equal to 10 kilonewton at the 10 kilonewton at the bottom node. And in this case itself we'll define another load which is called member load, or you can assign a uniformly distributed load here, uniform force. Let the uniform force be 5 kilonewton per meter, and let it act in the global y direction, that is let it act in the, so we'll vertically downward, so we'll mark it as minus 5 kilonewton per meter. So with that, add the load. Now assign this load in the top, use cursor to assign. So we have assigned a uniformly distributed load at the top member. So with this we have completed the loading assigns. Now moving on to the material, all has been defined as the concrete. If you need to change the concrete, we can move to the concrete and edit the values, that is you can edit the compressive strength. For the time being, let that be the default value. So with that we have completed the section properties and the inputs which we have to give. Now moving on to the next one, analysis bar print. So print option, print all, and so with that the analysis print option is also given. Now moving on to the command analyze, run analysis, save the structure, and we have seen 0RS and 01X. So staying in the modeling. Now moving on to the post processing, you have only one load, so you can see the displacements. The values are given here, horizontal, vertical displacements in all the nodes, and you can find the reactions on all the 3 nodes. That is on all the 2 nodes where the supports are there, we have the reactions. Then when we go to the beam, we can find the Fx, Fy, Z, that is the forces and the moments in the beams. And when you move for graphs, you can get the values of the bending moment, axial forces, shear forces, etc. for all the beams. That is for the beam 1, for the 2 beams, and we can get the values for the columns also. We can get the values for beams and also for the columns. That is, there are different that is you have bending YY, bending ZZ, torsion, stress, shear force along Z direction, shear force along Y direction, axial force, etc. You can find the directions for each. So with this we have completed the 2-dimensional analysis, that is analysis of a portal frame.